Good morning, everyone, and welcome. You'll see as you enter the webinar this morning, or I guess this afternoon, this evening, wherever you are, that we have a little poll for you. So as we're waiting for everyone to join us, please go ahead and answer these couple little questions we have, just to get a feel for who's joining us and what your level of knowledge is of this topic today. Thanks, Hassan, for sharing your intro. We do still have folks actively joining. So for those of you who've just entered the webinar, welcome and thanks for joining us today. Just take a minute to answer this quick poll. Tell us a little bit about who you are, where you're coming from, and a little bit about how familiar you are with the topic of trims. Give us a little something to consider as everyone filters into the room today. All right. This is a pretty big topic. So while everyone continues to come into the room, I'm going to go ahead and kick things off. So once again, welcome. Thank you all for joining us today. My name is Sarah Coulter, and I'm going to be hosting this session today. The agenda today is going to be pretty straightforward. We'll be doing a round of introductions. I will give an overview of the report that this working group recently published in October. Then I'm going to facilitate a discussion with a couple of the members of that working group to talk about the work, talk about their perspectives on it, and where we should go from here. And then we're going to talk a little bit about what that means for our next phase of work, take some questions from you all, and then we'll wrap it up. So let's dive in. For those of you who may not be familiar with Accelerating Circularity, we're an action-oriented nonprofit with a mission to build circular systems that turn used textiles into new raw materials. And that is in service of our vision of a world in which textiles are no longer wasted. And I'm joined from our team today by our newly appointed CEO, Eileen Malkus, who had previously served as our COO, and before that was a member of our board, and our project specialist, Ellen Fry. They'll be supporting on this session today. Just a little bit of background about Accelerating Circularity. We know that there are, anywhere from about 92 million to 110 million. Let's just call it 100 million metric tons of textile waste, landfilled or incinerated every year. That's a huge loss of value. We see that not as waste, but as an opportunity to transform those textiles into new raw materials. And we know that that transition will help reduce the textile industry's GHG emissions, conserve virgin resources and lessen social and environmental impacts. And so what accelerating circularity does is develop circular systems to enable textile-to-textile recycling. And our approach is to work with the entire value chain, from brands to recyclers to collectors and sorters, and all of the supporting industries that are adjacent to all of those partners, to turn post-consumer cotton and polyester feedstocks into high quality fibers, yarns, and fabrics that are suitable for mainstream commercial applications. There are a lot of initiatives that focus on a single recycling technology or a material stream, but we really believe that we need to cover the entire material recovery and manufacturing process. And so we're trying to bridge the gap between discarded textiles and scalable, economically viable recycling systems, and really trying to offer practical solutions to help companies meet their recycled content goals and reduce emissions while advancing a more circular and sustainable textile economy. So a little bit about the Circular Systems for Trims and Ignored Materials, which we shorthand as SYSTEM working group. This group formed because really leading manufacturers in the trims space recognize that trims, adhesives, threads, laminates, labels, fasteners, etc., are among the most common contaminants that need to be removed to enable effective T2T recycling. And so they came to us requesting to convene a group of experts in this field from companies specializing in trims and finishing technologies. And so the group is made up of experts in material science, product application, recycling, innovation. And they had some really concrete goals around mapping the landscape of trims, around material composition. What are the challenges of trims and ignored materials, specifically related to sorting, deconstruction, pre-processing? What are the opportunities around scaled trim material retrieval and management, and really thinking about frameworks and recommendations that can support product design compatibility with circular systems, and thinking about standards and classifications, again, to enable scaled circular systems. So with that, I want to quickly introduce our panelists today who are joining us from the System Working Group. First, I'll introduce Sarika Bajaj. She is the co-founder and CEO of Refiberd, a startup that uses AI and computer vision to sort textiles for resale and recycling applications. Their first AI model uses hyperspectral data to accurately predict the material composition of textiles within 2% of actual composition. This serves as a critical unlock for the textile recycling industry. Their second and newest AI model automatically detects brand, garment type, and quality to determine if a specific garment is resellable and what channel would be the best for resale. Prior to Refiberd, Sarika pursued textile research at Carnegie Mellon, where she completed her undergraduate degree and master's degree in electrical and computer engineering. And she also worked at Intel and SRI International. Joining us from YKK, we have Brian LaPlante. With a career focused on design and sustainability, Brian has been at the forefront of sustainable product design and material innovation. As director of outerwear at Marmot, he was one of the early adopters of recycled and sustainable materials and the use of PFAS-free finishes. Now, as senior manager of sustainability for YKK, he's focused on garment circularity, development of next-gen sustainable materials, and low-carbon production processes. Working with many of the world's largest brands, he's involved in the challenge of making textile-to-textile recycling a reality. We're really excited to have both Brian and Sarika with us today. Their contributions to this workstream have been invaluable, and I think we're going to have a really great conversation. So before we get into that, I just want to share a little bit about who else has been in the group with us. These are the sort of founding members of the group. So that's YKK, Nylorn, Avery Dennison, Refiberd, Tomra, and Bemis. And here's Brian and Sarika. And now a little bit of an overview of the report. So over the past 24 months, the system working group conducted in-depth research and knowledge building to really get at those key challenges that I mentioned before. And the idea was to draw from the working group members' own primary resources and expert knowledge, research trips that the group conducted to sorting and pre-processing plants, accelerating circularities, internally developed data assets, and in-depth stakeholder interviews with leading organizations across the textile circularity value chain, aiming to figure out how all of these entities are currently managing trims, sorting and pre-processing in the current textile-to-textile recycling system to identify their capabilities, innovations, and operational challenges. So the difference here is, to go beyond presenting a summary of the landscape of existing solutions and gaps. What we wanted to do is offer insights and recommendations for overcoming the barriers to scale and really find calls to action for designers, sourcing professionals, manufacturers, et cetera, to advance practical, scalable T2T recycling systems for the world as it is now. We saw in early stages of our research that there was a lot of really good landscaping work that had been done. And so it was clear that we wanted to take the work to the next stage and see what is actually scaling and how can we help that advance to the next phase. So to set some context, here we have a little diagram of the elements of the circular system. So you can see we've got collection here at little dot number 1, all the way through to brands and retailers. And we're going to focus in our discussion really, on the parts where the trims have the most impact in this system. So collection and sortation for pre and post consumer textile for reuse is really well established. The process to optimize and commercialize sortation for non-reusable textiles for recycling and or downcycling is still emerging. And that's where we see the challenge of trims emerge. So the actors with a major role to play there are the brands and retailers who select trims that are suitable for circular T2T systems, as well as the fabrics for circular systems, the trim suppliers, of course, sorters, and recyclers. So in our discussion today, that's really where we're going to focus, less on the dots that you see on the sort of bottom part of this system. Of course, we'll also be talking about some of the more supporting industries that are not captured on this diagram, like equipment, technology, data logistics, traceability, but they're all, increasingly important to scaling this system. So let's talk a little bit about how post-consumer textiles actually become T2T feedstocks. What you're looking at in this picture is just a bunch of mixed rags baled up. And you're looking here at someone styling and photographing a secondhand garment for resale, and our visualization of the spent textiles hierarchy. So the reason we're showing you these particular graphics here is because it's sort of 3 views into how this sort of cascade of value works. So When post-consumer material arrives at a sortation center, let's say it's been donated to a charity or a for-profit bin. When it gets to the sortation facility, it's very quickly assessed by a skilled sorter for immediate resale opportunities. Um, Other resale grades might be taken into account, but if it's not deemed sellable in this very first assessment, it's either processed for other channels or sold on as mixed rags. Mixed rags can be bought by, you know, again, other grading houses or for other resale channels or other outlets elsewhere in the textile use hierarchy. So you see domestic reuse resale on the hierarchy, you see international reuse and resale, you see wipers, you see shoddy. But after all of those reuse and resale channels, that's where the pool of textile to textile feedstock comes from in an ideal world. So there's all of this rapid human-based sortation that happens first and many potential resale channels. So there's already been quite a bit of handling and processing that happens before we get to the pool of T to T, potential T to T feedstocks. So let's keep that in mind when we get into some of the discussions later about the cost of developing these feedstocks and the labor considerations, et cetera. So getting a little bit more technical. So textile to textile recycling today, the feedstocks are focused primarily on pure cotton, pure polyester, polycotton blends, and there's a little bit of nylon and wool. And there are three basic recycling processes. There's mechanical recycling, there's thermomechanical recycling, and there's chemical recycling. We have a textile to textile primer that gives a pretty comprehensive overview of these processes. Ellen, if you don't mind popping that in the chat. If you're unfamiliar, that's a good resource to just look at for that. But that means that the first step in developing textile to textile feedstocks is to sort by fiber type. Beyond that, though, each actual individual recycler has really detailed requirements on the format that the feedstock needs to be, the size, and any restrictions that disqualify the material from its process. So, if there's a particular fiber that's absolutely not allowed, chemistries, finishes, trims, embellishments, anything else that cannot go into its process. So in order to become a textile to textile feedstock, post-consumer textiles have to meet not just strict recycler specifications for a type of process, but for the specific process of one of the hundreds of potential processes that could be targeted. So to put it really concretely, Accelerating Circularity has a recycler directory that has a couple of hundred recyclers in it. And many of them have provided us privately their specifications. Half of them, I think, have privately disclosed their specifications. And they're all different. They're all different. So every recycler that we interviewed as part of our system-specific research has very distinct requirements for acceptable feedstock. So different fiber blends, content thresholds, trimming, and chemical finish tolerances. And the absence of shared standards or common certification processes for feedstock quality means that each new vendor supplier partnership with a recycler requires really bespoke negotiation and trialing. And it's a really siloed landscape that increases operational costs and discourages investment in scalable pre-processing and limits the interoperability across the system. It creates inefficiencies for brands and collectors who want to support circularity, but really can't navigate all of these multitude of technical and material demands. So as a result, The development of harmonized specifications and data sharing frameworks is, we believe, a foundational step toward achieving a scalable integrated system. There's just a little bit more detail here that goes into that. But I will move on to the next slide in the interest of time. Here's a little case study that illustrates this. So in Accelerating Circularity's post-consumer programs, we partnered with Homeboy Threads and LoopedWorks for production-ready fabrics. And as part of that project, Homeboy provided a development of fully prepared 100% cotton feedstock in a 50-50 post-industrial, post-consumer blend. And that's going on to, it's actually on its way to be knitted right now. The price of that feedstock was $2.50 a pound. Not cheap, actually still pretty competitive in the overall landscape of what these things cost in the US right now. Homeboy is a diversified social enterprise, and its threads business prioritizes resale and is increasingly building out its T2T business. They identified two major unlocks: stable demand and payment from T2T recyclers, and reliable and consistent customer partnerships willing to pay fair rates for diversion. Meanwhile, LoopedWorks is operating at small commercial scale, manually sorting and pre-processing post-consumer and post-industrial textiles, and is forming partnerships to build out its vision, which is sort of a scaled community manufacturing hub sort of operation. They are both, really innovating on their business models, but they each depend on a unique set of tolerances for contamination, fiber ratios, and formats. They really struggle to deliver the to spec without overinvesting in individualized pre-processing. And this is, I think, a key area where we can see where the lack of standardized feedstock protocols has slowed, shared infrastructure and the development of, sort of universal QA tools. Homeboy is, with what they're doing, they're really leading the way in terms of what they're able to deliver at that price. But doing it in this bespoke fashion, like, it's still very, very challenging to scale and get to, a really market, economically feasible price. So, Tiara, you launched the quiz, right? I think you did. So there was a little quiz, and now we're going to find the answer. So that little case study, of course, tells us that we need automated sorting and pre-processing. So here we are, talking a little bit about that. Of course, automation helps us increase throughput, improve accuracy, reduce labor costs. However, there are still challenges. So we see a little table here that shows us, in a typical automated system, what we can expect to recover due to the presence of trims. So a t-shirt, for example, that has minimal trims, we might expect to see through an automated system 90% recovery rate. Jeans, 30 to 40% recovery rate because it has so many trims, all of the hardware, seams, whereas a piece of outerwear, which is multi-layer, has lots of trims, that's not going to make it into the system in the first place. A human is going to ensure that doesn't get on the line in the first place. So just wanted to leave that insight with you. You can pop in the chat if you got that right or not. But again, barriers to scale in automated systems, we find the same challenges that we do in manual. There are not standardized input requirements. The investment in the infrastructure is pretty heavy. And there is a need for clear market commitments from brands and manufacturers to, sort of make the case to build those investments. So the scalability of this really hinges on demand signals from brands and clear specs across the value chain. So even, the economies of scale that automation might enable don't really make sense without those demand signals. That brings me to advanced recycling. So I don't want to make the audience feel that it's all doom and gloom, because it's definitely not. In speaking with recyclers, we see insights about how pre-processing is actually happening in parts of the industry that are beginning to scale. So in advanced recycling, where there are investments happening in commercially scaled plants, we find in interviews with recyclers that increasingly many of them are taking on the challenge of feedstock preparation themselves. You see some snapshots here of green and of Cyclone's processes. And they really gave us some interesting insights. And they're emblematic of conversations we've had with many in the industry, that because their feedstock requirements are so precise, and because the investment in their plants is so substantial, they are willing to make the additional incremental investment in the final sortation and pre-processing in order to ensure that what feedstock goes into their system is exactly what they need, which potentially unlocks for us the opportunity to develop what we've been calling for earlier in the report, which is more harmonized, less bespoke feedstock standards. So if the Greens and Cyclones and other advanced recyclers of the world could accept a slightly broader general feedstock, do the final QA and pre-process themselves on their own property and their own plants, then we're well on our way. And we are starting to see this trend based on our research and stakeholder interviews, that this is what is beginning to happen. And so if that is the case, then that leads us to our next potential steps, which is convening all of these parties to talk about how we can actually achieve that together. So, there's a lot more in the report, but we do make some explicit recommendations for sorters to invest in automation, for recyclers to align specs, for tech providers, for brands, and for funders and policymakers. But I do want to turn the platform over to Brian and Sarika. Let me just adjust here. So you two have been working with us now for quite a while. And I'm curious to know, what brought you to this work stream? Why is it important to your companies, and why now? Either one of you,
Brian.
Well, for us, this is important work in the fact that
And trims have been considered a disruptor within recycling systems for such a long time. And we really wanted to understand where the challenges were within both the sorting and also the garment processing, and try to see if we could develop new products that would work more seamlessly within these systems and take away some of those pain points that pre-processors were facing.
Totally. And then for us as more the technology side, I mean, really trims is one of the first conversations we always have when we're, especially as a technology provider, we tend to find ourselves somewhere being ecosystem players, right? Like we tend to have like some partnership with sorters, some partnership with recyclers, and trying to stitch this path of finding feedstock and where can items go and what are the best value chain for, the partners we work with, because as we'll talk in details, like the economics are what's driving the system, and you really have to kind of prove that everyone can get some revenue out of this to make this work. But trims, I would argue, is the biggest discussion point, right? Because we need to be very specific on what materials can be sorted out and then processed and then can go to the next steps. And that intricacy, when we go from the abstract to the actual in terms of how to actually make a recycling path, is really where I think a lot of the difficulties come in. So, yeah, trims of paramount importance.
Thanks for that. Brian, YKK is one of the most well-known incumbents in the trim space. And given that position, what coming out of this work were the solutions and recommendations that were the most compelling to you? And where do you see the biggest challenges to advance them?
It was going into this work, it was really very interesting to just understand the whole landscape, particularly around garment pre-processing, because this is one area I think that a lot of people are not aware of within the whole ecosystem of recycling. And one of the things that we really wanted to understand was what was the capacity for the system to handle special trims designed specifically for it? We've been getting a lot of requests from customers to develop mono-material trims, things along those lines. And we've done a lot of research on that. Unfortunately, mono-material does not work as well for zippers and slide fastener type of products. They're just not as durable. So there's a real challenge within that. Are you designing a product for its end of life, or are you designing a product for the higher levels of circularity, which is longevity, durability, and repairability? So it was really a great insight into the challenges within in the system overall. And one of the big learnings that we came away from that was how to be able to design products that would work potentially in future systems as we improve feedstock specifications, as we improve technologies, things along those lines, but would also maintain that durability and longevity that we were looking for. And it also made us realize too that this is a really complex topic, right? And that we need to look at a bunch of different situations for different type of environments. What works in an open loop recycling system is very different than what works in a closed loop system. And I think having that understanding and being able to engage with our brand customers in a dialogue to help educate them, it's been really beneficial in a lot of ways. And it's also helped us really look at our own development for developing trims that can be more easily removed and processed within these systems.
That's such an important insight. I want to come back to the open loop and closed loop systems, but before we do that, Sarika, sort of same question to you about the solutions and recommendations challenges that are sticking with you the most.
Yeah, I mean, I think the biggest part that's sticking to us the most is just, the economics of the whole solution, how to kind of really get that process, development through as really as you touched upon earlier in the call, especially, I mean, with the challenges that like things really aren't consistent in the industry today, there's been a lot of struggle in terms of like, okay, do people invest in a large scale technology that then, like a main recycler looks at and then says, oh, actually, this isn't going to work for us. So how do you kind of unlock these like technology implementations, these technology applications for an industry that's still trying to very much figure out the different parts of this. So, I mean, like I think that has been very interesting for us to dive into because, we tend to talk about economics and what are going to be the drivers to unlock some of those projects quite literally every time on the call. So we that's been really insightful, which is nice. And then I think the switch between the theoretical and the actual again, it's like again in the specific cases of different feedstock streams, of the t-shirts, of the jackets, like that's where one can get really interesting also in the economics to be like, okay, if we make one stream more expensive, one stream cheaper, how does one really think about like what is the best area for a recycler to grab, or new recycling technologies to develop to maybe capture parts of the market that today can't be used.
Yeah, absolutely. Thanks for that. In our prep call, you used the word dissonance, and I thought would like really grabbed everyone. And, that having to transform while you're also operating in an existing infrastructure system, and the challenges around that. I would love it if you could speak more about that.
Oh, absolutely. I mean, we have to, and I think this is really what we also talk about a lot is this, the textile industry is a very, very legacy established old industry, right? And at the same time, we have the fact that the recycling is quite new in terms of what we're doing, especially when you come to like, the thermoplastic or the chemical recycling, or just even the notion that like, even for mechanical recycling, this is now shall we say, more socially acceptable route as compared to what may have been hidden in the past, So given the fact that it's a very new market, at the same time you're having all these legacy players trying to figure out how to play in this new market, there is, well, to use the word dissonance, right? There's dissonance in terms of how does one prototype quickly or invest in new technologies or think about how to experiment with new business models, to make these sections work. I think anything that players can do to have some flexibility on their side and be like, okay, not everything is going to be figured out because quite literally no one has, but let's sketch out these small paths as proof points, would really, I think, go a long way in terms of converting some of these theoretical answers into literal answers, right? And being like, okay, a real investigatory process through like a brand actually sending thing to recyclers, but tracking every step of what is being cut out, what's not being cut out. I would even be surprised if a lot of people have an insight onto some, like on the quiz survey, it's like, oh, jeans have 30 to 40% reclamation rate, right? Like in terms of a single gene. That knowledge is what's going to make so much of a difference at each of these steps that um, we really need to get into the weeds of it.
Great. And then one final question for you both before we turn it over to the audience for a Q&A. What do you see as the most critical supporting levers to enable circular systems with respect to trends and preparation and scaling of feedstocks?
Wow. I think there's several. One, I think that brands need to start designing more with an eye towards not only garment end of life, but also the other higher levels of circularity, durability and repairability, and really think through the entire life cycle of the garment that they're designing, and also emotional durability. So it's a big factor in there. So I think that's one big thing from the brand side. I think there's also going to need to be support on the policy side to help stand up recycling. And also, if we look at California and the SB 707, are the eco-modulation fees going to be high enough to help support the ecosystem of recyclers, sorters, pre-processors to support the recycling stream? Because if it's not, we can't stand up that entire ecosystem, right? And then there's going to have to be an additional investment. The challenge, a lot of the money's been flowing into the recycling technologies, which are starting to scale up and show promise. But now that money really needs to be funneled into the garment processing and sorting area, because that's really where we need the capacity to process feedstock so that we have the feedstock for the recyclers to use. So I think those are the three major areas I think we need to look to for the future.
I mean, I would echo all of that. I think especially in terms of like accessing new technologies, right? Like I think we have been seeing something very similar. And part of the challenge in terms of this funding is there is a general belief in the industry that okay, like, recyclers will get a lot of funding and brands have been able to directly support them because oh, their fiber product will re-enter their supply chain. That's a harder line for I think brands to really tie into in the processing stage. However, there is recyclers still, even with the amount of money that they've raised, are still financially constrained with trying to set up their first facility for the first time, that they don't have money to necessarily fund a new industry that's coming up on the sorting side, right? Like they definitely will have the money to purchase feedstock at scale, but there is iteration and testing and R&D that has to take place. One thing that I think the sorting industry can do to help with that is just design from, shall we say, like a more modular approach. Do we have to have like a really big, giant established system from the start, or can we be more flexible in terms of like allowing for partnerships, allowing for like, okay, one person's going to take this part, another person's going to take this part, and net together, can we kind of Frankenstein together a system that works to, solve this specific use case and solve this specific problem, and at least get more data in terms of what is the most efficient path. So, I mean, yeah, absolutely, absolutely echoing everything that Brian said.
Amazing. Thanks so much. So I want to wrap this section before we go into the Q&A by just letting everyone know what our next phase of work is, because this may inform some of the questions that we get. So we are actually intending to move system forward by helping to develop unified sorting fractions and also practical implementable design resources for brands and retailers, because these are the two recommendations to the industry that we feel our coalition's expertise, knowledge, and networks have the most ability to support. And so we invite everyone on this call to join us, and or at least to reach out and find out more, and see how you can participate in that work stream. So now I'm going to pass it over to Ellen to help us facilitate the Q&A.
Great. Thank you, Sarah. Thank you, Brian and Sarika. We've got one question here from Alejandra. If a t-shirt is printed with something like plastisol, or if it has a heavy embroidery, does it get removed? I'm going to let Brian or Sarah take that one.
I'll let Sarah go ahead and take that. But from my understanding, plastisol is a real problem within systems. So that would have to be removed.
Yeah, typically, I mean, the answer is always, it depends. But generally plastisol is a no-no in most any system. It's going to have to be removed in some way.
Thank you. And don't be shy. Please drop your questions in the chat. We've got another question here from Shamini. To what extent do you see brands working with textile recycling plants on a total integrated approach, understanding that the goal would be to develop designs with trims and materials that will seamlessly be accepted in T2T? Let's see.
I can jump
Sarah,
in.
Oh, Sarah could go for it.
At least for us, okay, so I think this is a multi-layered question, so I'll probably break down step by step. At least I have not seen a lot of brands necessarily work on plant development itself. I argue inherently that's not a bad thing in the sense that, like, I think keeping that on the chemical or like mechanical side where it's very process flow is probably preferable just to really drive economics there. But of course, what you still need to see is like the brand purchasing and the commitments to kind of tie everything together. I think the discussion around design for circularity has been coming up, at least from my perspective. I'll probably let Sarah and Brian take more of that. What I will say is it's usually it's as we kind of allude here, it's a little bit more complicated than we even realize sometimes, right? Like even if suppose one switches the thread material that things can immediately go into the process, just the fact that there is some extra thickness could clog a machine that is doing some shredding, right? Like it may not actually just be the material itself that's a problem. It's the fact that there's difference in textures and difference in all of this, and machines like everything to be regular. So that's part of the problem here too. Of I think the goal of design for circularity needs to be the end goal, but I think there's going to be a lot of process in whether it's material and form factor to make that work.
Yeah, and just to echo on that, I also see the same thing. I see brands really engaging on off-takes with recyclers, but I don't see as much action happening around designing for circularity and really understanding the entire process garments go through to be processed into feedstock. And so there's a big knowledge gap there that really needs to be closed.
Actually, to really echo that point, because I think it's an important one, um, I don't, I think there's a huge, people don't understand really what's in the clothes from the brand perspective. Like, even though there's testing and everything like that, we've done several pilots where, sometimes our partners have come back to us and be like, we didn't realize there were 7 materials in this one sweater that really didn't need 7 materials, right? Like, one has to really, I think, look back and carefully go through what exactly is being sourced at what stage. And there's a lot of missing information there today.
All right, thank you. We've got a question about if a garment has PFAS in the finish, will it be rejected? Sarah, I'll give that one to you.
Yeah, so this is again an it depends question. So even in an automated sorting system, there's not really a way to detect that. In a chemical recycling system, there may be, strategies to manage that in the recycling process itself with filtration and chemical treatments. But there's not, it could be tested for and rejected in that way, but that's not going to be an economically viable way to handle those products and materials.
Great. We've got another question about what about solutions for design for recycling from brand manufacturers at the start, specifically for automated disassembly to help alleviate and separate the trims that disrupt in a lot of recycling processes? Or will this be addressed in the next phase?
That's really what we're looking to in the next phase of our work, is really to try to establish some design guidelines around that area. In the perfect world, right, recyclers would like to have garments with no trims whatsoever, but that would make it a little challenging for us to clothe ourselves. So we need to find a happy balance between the two. So I think that's really what we're going to be focusing on our next phase.
Thank you. We've got another question from Mark. What happens when the trims are removed from the garment? For example, zippers, are they collected and molten to generate new raw material, or what happens to these?
A lot of these trims, especially anything that has any type of metal value to it, will be sold off to scrap metal and then remelted down into recycled metals of different types. So yes, a lot of, the business of recycling is to try to get as much benefit from the materials that you are going ahead and processing. That's just an important part of your revenue stream. So if something can be, resold, they will certainly try to do it.
And Brian, that would also be applicable to horn, shell, wood buttons, correct?
Possibly. The challenge with that is, remember, everything's going to get chopped up into little bits. And so once they get chopped up into little bits, some things have value, other things don't. It's very easy to separate out metal. It's much harder to go ahead and separate out horn or ivory type of buttons. Much, much more difficult. And typically those end up as waste.
Thank you, Brian. We've got another question here. What is your advice to a textile material management company, parenthesis, sorting and collecting, resale, upcycling are the current activities? Who wants to expand into recycling in the future?
I can take this one. I would say definitely make sure you have steady revenue streams before we get into recycling because it's still, I would say, like, especially it's companies who are trying to get into this as their main revenue market, right, are running into difficulties right now because the industry's still growing. I do think the best thing can do is like try to have these recycling relationships set up from the start to just run tests. Like send sample feedstock, understand what technology is needed, experiment and really get a sense on the specifics on how does a recycler think about your material and are they really interested in like sourcing this long term? We often see sorters fall into a trap where they tell us like, oh, their feedstock is completely fine. But then when we talk to the recycler who's actually been playing with it, they're like, actually, this is quite rough for us. And the minute we get better material, we will hopefully not sort from this until processes improve. So I think like just trying to get very into the nitty-gritty about what is your actual material stream, what are the actual challenges with your feedstock, and how do your economics play into the longer game is going to be the discussion of really with these recyclers to make sure you're making a long-term sustainable play here.
And just to piggyback on top of that, I think it's really important to do the trialing with a lot of different type of recycling processes because what
Yes.
might work in mechanical might not work in chemical. So it's really important to make sure that you hit all those major type of recycling technologies when you do your trialing.
Also throwing it out there, we've talked a lot about technologies in this space. Manual detrimming is still a big part of this story. And so let's not, like especially if there are areas where the companies are located that manual detrimming could be an option from a labor perspective. Like I think that's an easy win, especially as the other automated technologies are still working on scaling.
Great, thank you. I think we've got time for one or two more questions. We've got a question from Allison about heat transfers or heat transfer labels that are applied to a product. Are these easily removed or does this pose an issue?
No, heat transfers are not easily removed for the most part. So that can be a challenge. There are some heat transfers that will have less impact, which is definitely something that you can use on products. So it's just a matter of talking with your supplier about the type of offerings they have in heat transfers.
Thank you, Brian. And I think we've got time for one more question from Claudia. Can you further explain the pros and cons between mechanical versus chemical recycling?
I can take that. I wouldn't necessarily say pros and cons. I would just describe them as having different attributes. With mechanical recycling, the main attribute is that the product that goes into the process is the product that comes out of the process. So if we think about mechanical cotton recycling, you put in cotton and you get out cotton. Whereas with man-made cellulosic, the chemical cotton recycling, you put in cotton and you get out a chemical cellulosic, a man-made cellulosic product. So it's transforming that cotton into a different material. So they're different technologies. With thermomechanical polyester recycling, you put in polyester, you get out polyester. You're melting, you're shredding, you're melting, you're re-extruding. It's the same plastic, essentially. There may be some changes in terms of, the quality of the plastic. But again, similarly to pure mechanical recycling, what goes into the process is the exact same material that comes out of the process. The sort of promise of chemical recycling is that you are returning those materials to their pure first gen state. And so you're actually taking materials back down, you're breaking them back down to a molecular level, and then rebuilding them back up to a first gen material. So they're just very different processes. They have different attributes. If you want cotton to come out of your recycling process, you pretty much have to stick with mechanical recycling. With polyester, it's some of it's about what's available, some of it's about what are the economics, what's at scale. They really have different attributes, and not necessarily pros and cons. It's really, what are you trying to achieve, and can this technology deliver that for you?
Great. Thank you, Sarah. That will conclude our Q&A, and I will drop our contact information. If you have any additional follow-up questions, you can reach out to the Accelerating Circularity team. Okay, and I'll hand it back over to you, Sarah, for closing.
Great. Well, I just want to thank once again Brian and Sarika for joining us today. It was a great conversation, and I wanted to thank you and everyone in the working group for your contributions to the work the last couple of years. I'm really looking forward to continuing in the coming year. And for everyone that would like to dive a little deeper into the work in the report, you may download the report here. And for any further questions and to find out more about joining us in the next phase, please email us info@acceleratingcircularity. Thank you so much for joining us.